So this video is a review of inventory theory. So let's first start out, why do we have inventory? So if we think about why we have inventory, well, it can exploit economies of scale. And that's exactly what the EOQ, the economic order quantity, does, is it exploits the fact that we don't want to keep placing a bunch of orders. Instead, we want to place one order and pay for that shipment for a lot more quantity of products. So it can exploit those economies of scale. It can also decouple or separate various parts of the production process. And so we're seeing that right now with COVID, is if we have inventory downstream towards the customer, even if the production facility got shut down. So in a lot of agriculture, food supply chain, a lot of the meat packing plants are shut down because of COVID. We still see meat in grocery stores because there was inventory in the system. So that was decoupling these processes. Another reason is we want to have inventory to the fact that we might not know exactly what the demand is. And so we use inventory as a buffer against variability. And so this is why retail locations have inventory, is that they have a hard time predicting exactly the demand for a specific product in a specific location, a specific day. And so they have a little bit of safety stock so that we have less stockouts. And so that's another reason to hold inventory. And another reason is to hedge against inflation. So if you think things are going to get really expensive down the road, you could buy it now at a cheaper price, which is a reason, again, to hold inventory. So these are all really important reasons to hold inventory, but inventory is also really expensive. And in fact, it's one of the company's most expensive assets. And so the whole idea of inventory theory is to have inventory for these reasons, but have as the least amount you need to accomplish these goals, okay? And so when we think about inventory theory in this class, we thought about really 1, 2, and 3. We didn't talk as much about number 4, but we talked about different models that incorporate the positive aspects of inventory, but we always consider that we need to balance holding costs. So holding costs is the cost the company has to invest in this stuff before they actually get the profit or the sales out, okay? And so in terms of what types of models we studied in this class, we primarily studied 3 major kind of models. So the first is the EOQ, or the economic order quantity. In terms of getting a degree in industrial and management engineering, as I shake your hand across graduation, you should know what the EOQ model is. It's like a fundamental principle. And so we studied that. It's very basic. It makes a lot of assumptions, specifically that there's deterministic demand. But it's worth studying because there is good information about that, specifically the holding versus ordering cost balance. And then secondly, we use that to set Q in the QR model, which incorporates uncertain demand. And so the QR model orders Q when we hit R. And so there's lots of, now we're balancing the holding and ordering costs with the stock out costs. And we also studied some other variants of that, and specifically how safety stock changes between aggregation and centralization. And then we studied the news vendor model, which is, again, having uncertain demand, but we place an order before the selling period. And the difference here is that the inventory loses some value at the end of the selling period. And so in terms of the final exam, we haven't been tested yet on inventory. So inventory will show up in both the conceptual part as well as the written part. So you should be able to do basically the homework 3. All of that material, which covers all of these different models, is applicable in the final exam. All right, so let's go into detail a little bit more. So as a reminder, what does the basic EOQ model do? It balances the cost every time I have to place an order with the cost of holding things. And when you think about ordering costs, usually that's transportation based. And so if you think about it, if I place an order for something to pay this fixed transportation cost that's really independent of how many things I order, and then so that incentivizes you to want to have bigger quantities of Q. But then if you have bigger quantities of Q, you order in bigger number of units, that makes the holding cost go up. And so it's balancing these two things. And in fact, we solved for Q star, and remember we took the total relevant cost equation, set it, took the derivative, set it equal to 0, and found the minimum value of that function, and that's the square root of 2SD over H. And if you use that equation to set Q star, which again is how many do I order, it gives you at optimality that the total holding cost equals the total setup or ordering cost in the system. So the EOQ model with quantity discounts is a variation of this that incorporates that if I place an order for more than some amount, that increases or decreases my product cost. So you can think about it, if I order 500 units, I get a discount. If I order at least 200 units, I get a discount, for example. And so when you think about relevant cost, now product cost is relevant because C, the unit cost is now a function of Q. I pay $2 if I order less than 100. I pay $3 per, or $1.50 per unit if I order more than 50. And so now we have the total relevant cost being this equation. And how do we calculate the quantity discount? How do we get Q star? We basically have to do a bunch of steps. And so we're again trying to find the minimum of a function, but the function is no longer continuous. And so we need to look at each breakpoint and compare then the total lowest relevant cost. There was a homework problem on that, and you should be aware on the final exam, why are different things relevant in this model versus the basic one, how to calculate Q star with quantity discounts. Those are things that are fair game on the final exam. Okay, so what should you do? You should know what the EOQ model is determining. That's how many to order. What it considers relevant. So it considers in the basic EOQ holding and ordering costs. And you should know why you hold inventory with the EOQ model. The EOQ model is a deterministic demand model. So even if you had a perfect forecast, you would still have inventory. And that's a huge insight into the problem. Why do you have inventory? Because you don't want to keep going to the store every day for one item. You don't want to keep paying for transportation. And so there are positive reasons to have inventory, even if you had a perfect forecast. You should also know what the assumptions of the EOQ model are. You should be able to use the equation to get what is Q star, and then know some of the properties. Specifically at optimality, the annual holding cost equals the annual setup or ordering cost. And it's a robust model near Q star. What that means is the total cost function is relatively flat near the Q star value. You should also be able to apply it when lead time is greater than 0. What that does is it doesn't change Q star, it just changes when you place an order. So the idea is you place it such that when your replenishment order shows up, it's right when your demand or your inventory level is 0. And so then it looks again like that sawtooth graph. And you should be able to apply the EOQ model with quantity discounts and understand now you have total relevant cost includes the unit price. That's because it's now a function of Q. In terms of uncertain demand models, we studied two major kinds, the QR model and the news vendor model. And I'll talk a little bit more detail about each of these. You should understand specifically on the conceptual part of the final exam, when are each models appropriate? What situations do they model? What is getting captured? And so one of the biggest differences between the QR model and the news vendor model is the QR model, you continue to place orders. You can continue to replenish over time. And the reason you can continue to do that is because your inventory is assumed to not lose value. You place an order for Q when it hits R, so you can do that multiple times. The major difference with the news vendor model is you place an order before the selling period, and at the end of the selling period, your inventory has less value. There is an overage and an underage cost associated with that. So these are models that are both for uncertain demand, but they're characterizing different environments. And so how do you do this? Specifically for the QR model, which is all about reorder points and safety stock, the key level is we really need to know the standard deviation of lead time demand. And so you should hopefully know these equations in nausea, that you keep using this equation of combining different periods together. You've used the square root of L times the period is the lead time demand. And so those will show up on the final exam. Remember, if I have if I'm given, let's say, daily demand, and you have 1 week or 7 days of lead time, you need to convert daily standard deviations to weekly. So it'd be the square root of 7 times the weekly standard deviation gives me, or daily standard deviation gives me weekly standard deviation. So you should be able to use these equations. You have used them a lot in both actually homework 3 and homework 4. So be able to use these equations. You should also understand how to incorporate both uncertain demand and uncertain supply. So that's when the lead time is uncertain. And the key takeaway, you should be able to use this equation, but the key takeaway is that as you have more things uncertain, you have even more uncertainty in lead time, which leads to even higher safety stock. And so being able to use this equation is fair game on the final exam, but also from a conceptual perspective, understanding the implication. And the high level implication is the more things that are uncertain, the higher the uncertainty of the lead time demand will be, which means you have to have higher safety stock for the same cycle service level. You should know the relationship between R, the reorder point, safety stock, and the expected demand during lead time. And specifically, there is this relationship. So R, the reorder point, is equal to the expected demand during lead time plus the safety stock. And so you could think about the relationship between the QR model and the EOQ model. The EOQ model has safety stock at 0 because we have a perfect forecast. We know exactly what demand is, so there's no reason to have safety stock. However, we would still need to place an order earlier if the lead time is greater than 0. And so what is safety stock doing is it's a buffer for the fact that on average, the replenishment order shows up and we have this much left. We don't know exactly what demand is, so we have an extra buffer, which is our safety stock. So please remember that this relationship is there. This is useful for many things. There are old exams that you should be working on. Those are good ways to study for the final exam, that you can use this equation directly. It's also a good thing to remember is if you're given one of these, you could calculate one of them and get the other ones usually for free based on the other input data. You should be able to apply the QR model. That's also fair game on the final exam. So one thing I want to emphasize is if there's normal demand, we can use the Z statistic. If demand is not normal, you cannot use the Z statistic. So the Z statistic is only valid for the normal distribution. What is the Z statistic doing? It's really giving you a cumulative distribution function, and it's transferring the fact that we have these Z values for normal distribution with a mean of 0 and a standard deviation 1, and it converts it to any normal distribution that doesn't have a mean of 0 and a standard deviation of 1. But it's really what it's doing is it's providing a cumulative distribution function. So that's what it's doing, is this, but you don't only have to use the normal distribution. You can have demand being non-normally, so it could be Poisson distributed, a discrete distribution, gamma distributed, etc. You just then need the cumulative distribution function to be able to apply these equations. And you should understand what are the average relevant costs in the QR model. And so what it is really the combination of what are the relevant costs in the EOQ model, that's this part of the equation, plus the additional part, which is the safety stock. And so you can think about, we need different types of kind of inventory. So we have the average cycle inventory, which is the Q/2. That's due to the EOQ model. The fact that you don't want to keep placing so many orders. You may want to not go to the grocery store every day. You want to go every 2 weeks and order more things. So that's the Q/2 part. That's called cycle inventory. Then we have the average inventory in transit, which is when I place an order to when it shows up. And you can think about how do we do that? Well, that's the expected demand during lead time. And that's because that's when we're placing an order. So that's D/L, the expected demand during lead time. And then we have safety stock. And so safety stock is the expected number of units when a replenishment order shows up. And so that's the buffer on average we have to buffer against variability in demand. And so if we want to know the total relevant cost in terms of holding costs, if you purchase and you pay for inventory at purchase, meaning everything in transit you've already paid for, that means your holding cost would be Q over 2 plus R. And remember, R is the expected demand during lead time, D of L, plus the safety stock. So it's basically all three of these summed up if you pay for inventory when I place the order. Some people don't pay for inventory until it shows up. And if that's the case, then you aren't paying for the D of L. That hasn't gotten to you yet. And you're only paying for the safety inventory and then half of this Q over 2, because sometimes you have Q and sometimes you have 0. And so on average, you have Q over 2. And safety inventory or safety stock, remember, is an expected value by definition. All right, so what should you be able to do in the QR model? You should understand why you have safety stock and what influences the level of safety stock. The key here is the cycle service level and the standard deviation of lead time demand. That's what influences how much safety stock. So any uncertainty drives up the safety stock, and then how good of service level do you want also drives up your safety stock. You should be able to calculate the safety stock, the reorder points for normal demand distribution, discrete demand distributions, or Poisson demand distributions. You should be able to apply the QR model. You should understand the relationship between safety stock, reorder point, and expected demand during lead time. You should know what applying a QR model means in terms of inventory management decisions, and you should be able to calculate safety stock and reorder points when both demand and lead times are uncertain. All right, so the other thing we spent a lot of time on is the centralized versus decentralized impact to inventory. And so the big takeaway there is that if I centralize my inventory storage, so I have multiple demand points or demand regions, all having inventory in a centralized location, that does nothing to change average demand. The average demand in a decentralized and centralized system are the same. But what we get as a benefit is we reduce variability by centralizing, or sometimes called pooling, of your resources. And this is true as long as the regions are not perfectly positively correlated. And so remember, what drives safety stock is the fact that we have uncertainty in terms of the standard deviation of lead time demand. So what we gain here is the average demand doesn't change. So that means the EOQ, the Q star, doesn't change. However, what changes is safety stock. And so why? Some intuition is the more inventory you have, the less likely you are to have what you need. And the more locations you have, the less likely you'll have the right product in the right place. And so if we want to quantify that, what actually happens in terms of aggregation is if we pool our inventory for both I and J, so meaning we have the inventory together, if one is big and one is small, we get to use the inventory for I at J. If we had them that they were totally separated, even though this one was big and that one was small, I can't like swap. I can't help each other out that cancel this big and small together. You may say sometimes, look, I mean, 50 and 49, I can't really help each other out. But then the next time when this is small and this is big, because it's pooled, I get to help. And that's why we really get this reduction in safety stock. And that can't happen if I treated this I all separately. So over here, if I had 99, I couldn't use some of the extra inventory here if they were separated. That's where the benefit is coming from. The other thing to think about is that safety stock is a concave function of demand variance, so as demand uncertainty. And so you would rather pool a bunch of things into one big, large variance, that's what's doing in the centralized, than a bunch of small ones. Okay? And so you should be able to apply these equations. This is something you did a ton with the Toyota problem in homework 3, as well as what you did at the end of homework 4 when you were combining different regions together. And so you should be able to calculate the safety stock when you aggregate them. Remember, this is from a spatial space aggregation. You might also have to aggregate periods into lead time. So you've had lots of practice on this on homework 3 and 4. Expect to see some of this on the final exam. So if you think about the trade-offs to inventory aggregation, if you have multiple stocking locations to a single one, there are advantages and disadvantages of that. So from a advantage is it can reduce our safety stock inventories, and it can also reduce our facility costs. However, it can decrease, or it can increase our response time to customers and also our transportation costs. So there's pros and cons. And you've again had an opportunity in both homework 3 and homework 4 to kind of explore, is it better to have one location or 3 separate locations? And so the answer is it depends, and you need to consider the inventory cost, the facility cost, and the transportation cost, and compare those two to determine which one is better. And so what are you responsible for? You should be able to calculate the expected demand and standard deviation of demand during lead time. In a decentralized or centralized inventory management approach, you should be able to calculate the safety stock for a decentralized system versus a centralized system, the total logistics costs in both systems, so inventory, facility, transportation costs. Remember that we calculate inventory holding cost. Some of the problems, we only cared about safety stock. Make sure to understand what are the costs, the relevant costs in the problem that's given, and incorporate that when you're doing the final exam. You should know the relationship between the number of stocking locations, safety stock, transportation, and facility costs. Understand why centralizing inventory reduces safety stock. And you should know which types are appropriate to centralize versus decentralize. So remembering to the Toyota problem on homework 3, you had to do a popular variant and an unpopular variant. And so it'd be useful to understand the trade-offs associated with what influences what decision in terms of why is it beneficial oftentimes to centralize slow-moving products and decentralize fast-moving products. In terms of the news vendor, that was our last kind of inventory model. You should be able to understand which setting is appropriate. And so when you think about what setting is appropriate with news vendor, there's a single opportunity to order things. And that single opportunity happens before the selling period. The selling period demand is uncertain, and there's this too much, too little challenge associated with if I have too much, then there's inventory left over, and that has some loss of value. If there's too little, I lose sales, is the typical kind of traditional view. But I want you to encourage you to think about things beyond just the traditional view. So this too little, too much, you had an opportunity to think about that in a non-inventory problem in the homework with the Amazon Go. I'd encourage you to keep thinking more broadly about when does this too much, too little implication happen. The idea is that the demand model is uncertain, so you have to describe what that is, describing it usually using a normal distribution or a discrete distribution, Poisson distribution, whatever. And then if you set it using the critical value, you are maximizing the order quantity that balances these two costs, or minimizes the cost or maximizes profit. And so how do you do that? First, you need to know what the demand model is. You need the cumulative distribution function, so that's key, cumulative distribution function. And so how you do this is you need to figure out what is your critical value, so the cost of underage and the cost of overage. Remember, these are per unit costs. And then once you do that, you choose Q star that is greater than or equal to that critical value. And if you do that, you get a value that maximizes the expected profit or minimizes the expected cost. And so what should you be able to do? You should understand when is it appropriate to apply the news vendor model, be able to apply it and calculate characteristics, things like critical factor, stock out, service level, expected profits. And you should be able to use it to apply it beyond problems of inventory. So remember, the structure of the news vendor problem, what I just went through, is applicable in things for inventory, but beyond. And so that will be tested also on the final exam. So you should also know, if you say, okay, when should I apply one or the other? Well, you should step back and say, what is the difference between these two models? So they both have uncertain demand. The difference is in how often am I placing orders. So the QR model is there's unlimited replenishment. So I can place multiple orders, whereas the news vendor, I can only place one, and it has to happen before the selling period. The other fundamental difference is the QR model, inventories assume the same value at the end, so it's not losing value, which in the news vendor problem, the reason we only consider one time period is that at the end of that, we don't have the same value of our inventory. There's been some questions in terms of how should I round? And so I know there's lots of words here. These slides are posted. There's also comments in a discussion posting on LMS about this. One key thing is that safety stock, the definition is that it's an expected number of units left over when a replenishment order shows up. And so by definition, it's an expected value. And so you shouldn't be rounding safety stock. So you could think about this is I come and when the replenishment order, the UPS guy shows up, I count how many units I have. And so on day 1, I have 10 units, for example. And then on day 2, when the person shows up, I have 5 units. And then on day 3, I have 3 units, right? And then day 4, I have 15 units, right? So all of those are integer, but what is the safety stock? The safety stock is the expected value. I would take the average of those 4 numbers, and that doesn't need to be an integer value. So you should not round safety stock. In terms of the other things, like Q in the EOQ model or the QR model, that's how many units should I order? And typically you can only order in integer values. And so then it does make sense to round. And you could say then, should I round up or should I round down? From the QR model, remember you set Q using the EOQ model. What you should do to make sure you have the minimum one is you should try both the rounded up and the rounded down Q and take the one that has the lowest total relevant cost. So similar to what you're doing when you do the quantity discount, you have multiple different total relevant costs and you take the one that's minimum. That's what you should do to make sure you have truly the smallest smallest total relevant cost to set Q star as an integer value. The simpler answer though is that remember the EOQ model is a robust model, which means that at optimality that total cost is relatively flat. And so the short answer is it doesn't really matter too much if you round up or round down, you aren't getting too much. So you can kind of round to the nearest and be okay. In terms of the news vendor setting Q, you should always round up. And the reason is that in terms of the overage and underage cost, it's beneficial, you have to round up. And the reorder point, you should always round up because you are setting it typically to meet at least some cycle service level. All right, so in terms of some key insights from inventory theory, there's a lot of these on the final exam, specifically from the conceptual side of the final exam. And so I think it is really key for you to understand trade-offs associated with inventory theory and also why you hold inventory. And so the inventory sometimes gets a bad rap. Everyone's like, I just want to get rid of all my inventory in my system. Lean manufacturing has a lot about reducing inventory, and there's nothing wrong with those principles, but you need to think about why you have inventory. And so the goal is not to just get rid of inventory in your system. It's there for a reason. And COVID is a good example of the positives of having inventory. If someone had a huge stock of toilet paper, they are now the geniuses of the world, right? So inventory holding is not inherently bad, but it is expensive. And so you need to think about how can I have the least amount of inventory to serve its purpose. And so that's what we really should be doing. And so you should not remove inventory out of the system just to remove inventory out of the system. You should change these levers and then let that lead to reducing inventory. So what do I mean by that? You can't just decrease safety stock without decreasing variability. So if you want to get rid of some of your inventory costs due to safety stock, you should decrease variability. So you may ask, okay, well, how do I do that? Well, one way you can decrease variability is by pooling of your demand into a centralized location. That reduces the standard deviation of lead time demand. You can do other things like improving your forecast. You could somehow get better forecasting information from all of your different demand points, and that would also reduce variability and therefore reduce your safety stock. So you can have as a goal reducing inventory, but the way you do it is you need to reduce what is causing the inventory to be there in the first place. And so how do you do that? If you can reduce variability of demand, that's great, and that will reduce safety stock. You could also reduce your lead time, and that will reduce your reorder point. You could reduce the setup or ordering costs. Every time I place an order, I have to pay so much. That would reduce your order quantity or your Q star. And so all of those reduce expected inventory costs, but it's by reducing these things like levers, like variability, lead time, and setups that ultimately lead to reducing inventory. And so my last slide here is, I think it's really important to understand why we hold inventory. And so there will be questions on the final exam, specifically in the conceptual part of what is the purpose of having inventory. If you have too much inventory, or if you have too few inventory, what does that do? Why does that exist? And there are different things. So you have inventory for the cycle inventory. Why do I have Q/2 on average? Is because if I order in Q and Q is big, I don't have to place as many orders. And so right now, if I'm going to COVID, I don't want to go to the grocery store. I'm going to order a lot more at the time so that I can reduce the number of trips to the grocery store. That is a reason to have inventory. You could also think in terms of the safety stock. You have inventory because you don't know what the demand is. And so I have a buffer. And so safety stock goes up as the variance or the uncertainty goes up. It also goes up as the lead time goes up because you have a larger time where you have to try to predict what's going to happen. And it also goes up as you have more stocking locations. So you don't know where the demand is going to occur. You have one more variable to try to figure out. And so you should really understand this. I think there's, in terms of the conceptual questions on the final exam, there's lots around the purpose of inventory. What happens if I do something? What happens to my inventory levels? How do you understand what's going on in terms of all these different models? So there's lots of questions on the final exam conceptually about